In this lesson, we are going to talk about how to use trigonometrical ratios to calculate distances and angles. If you do not know what trigonometrical ratios are, then you should go watch the video on Pythagoras' theorem and the trigonometrical ratios. If you already know about those, then let's continue with this lesson. Here we are going to talk about what the ratios are and their inverses, and calculate lengths using trigonometrical ratios, and also calculate unknown angles using these ratios. Quickly, if we have a right angle triangle and another marked angle in that triangle, then we can define three primary ratios, which ends up being 6 if we invert them. And associated with those three ratios are inverse trigonometrical ratios that we use to calculate angles. So these three directly are used to calculate angles, and these three we write them down especially to calculate the distances and sides of triangles. So there are three main ratios: sine, cosine, and tangent. And this is how we define them. Sine is opposite divided by hypotenuse, cosine is adjacent over hypotenuse, tangent is opposite over adjacent. We use this little acronym to remember it. Sine is opposite over hypotenuse, cosine adjacent over hypotenuse, and tangent is opposite over adjacent. We call it SOHCAHTOA. A lot of persons find it useful. This is our angle. So we say this side, which is directly in front of it, is called the opposite side. This side up right across from the right angle is the hypotenuse, and the other side is the adjacent side. And mixing up these sides, choosing two at a time with the angle that is marked, we get these three ratios. So we get sine when we say opposite divided by hypotenuse in relation to that angle. We get cosine, shorten it as cos. It is adjacent divided by hypotenuse in relation to that angle. And to get tangent, we say sine divided by cos, or the opposite side divided by the adjacent side. And like I said, these three are used to calculate angles. More on that later. Now, a little bit about calculators. Calculators are an indispensable tool when you're doing trigonometry. Back in the old days, they had three-figure tables, which were the thing at the time. Nowadays, it's modern technology, so we use calculators. You must be familiar with your calculator. Students often get a lot of errors in doing trigonometry because they are not familiar with their calculators, or they borrow somebody's calculator in an exam and are not familiar with how it works. So whatever calculator you have, as long as it is scientific, it will work once you get to know your calculator. Some calculators do pretty writing, such as these. They write it the same way that you would write it on the board, or the same way that it appears in the textbook. That is important. Some calculators do not, such as this one. So if you should press cos on this calculator here, or this one, then the word cos would appear on the screen. If you press cos on this calculator here, the word cos would not appear on the screen. So those little things are important. Also, it is important when you're doing trig to make sure that your calculator is in degree mode. Notice this little d here. It is important. Angles are measured in degrees and radians, and your calculator will switch between those modes from time to time. Somebody might borrow it and use it in a different mode, and then you're doing trigonometry and you forget to change it back. It's going to give you incorrect answers because you are working in the wrong mode. So the idea is that make sure that you know your calculator. Also, some calculators come with a shift button. Here we are. Here it is. Some calculators come with a second function button. They essentially do the same thing in that they give you access to whatever is written on the plastic here. Second function, so you have sine here, you have sine inverse printed above it, cos and cos inverse, tan and tan inverse. So if you press this button, you get sine. And if you use shift, press the shift button, then press sine, you get the sine inverse. If you press this one, you get tangent. And if you press shift first, then press it, you get tan inverse. Same thing here with second function. It gives you the same idea. But with these calculators, you kind of work things out in a slightly different way. And we'll talk about that in a little bit more, but in a little bit more detail later on. But essentially, you must know your calculator inside out. It should be like a part of your hand or an extension of your mind when you're doing this kind of work in trigonometry. Having said that, let's move on to look at some calculations. The first thing we're going to do is to calculate the length of a side. I'm going to write back that SOHCAHTOA idea. So we have sine is opposite over hypotenuse, cosine is adjacent hypotenuse, and tangent is opposite over adjacent. Now here we want to find the length of x. We have this side and we have this side. Here is our angle. Now let's go across from here. This side would be our opposite side. There's nothing there. We are not using it. But we have something here, and this side is our adjacent side, and this side is our hypotenuse. That little maneuver is very, very important when you're doing trigonometry. You need to be able to identify clearly which two sides you are using. If you do not identify clearly which two sides you are using, you're going to end up most likely choosing the wrong ratio and then end up getting the wrong answer. So first, we identify the sides. This is adjacent and this is hypotenuse. Now we say which of these ratios, which of these three have that combination of adjacent and hypotenuse. This one has adjacent and hypotenuse. So that tells us we're going to use cosine. So we write it down. The cosine of the angle is 50, is equal to the adjacent side, which is x, divided by the hypotenuse, which is 8. Once you write that down, it's simply a matter of cross multiplying. So we have x here is equal to 8 times the cosine of 50 degrees. Make sure that your calculator is in degree mode. If it is in degree mode, and if when you press cos on your calculator, the word cos comes up on it, then you should type in your calculator exactly the way it is right here. 8 cos 50 or 8 times cos 50. Either way, you will get your answer. So we're going to type that. 8 times the cosine of 50, and that should give you 5.1. We're going to write them to one decimal place in this centimeters. If your calculator does not, if the word does not come up on your calculator when you press cos, then to get your answer, you should write 50 cosine times 8 equal, and that usually gives you your answer. But if when you press cos, the word cos comes up, then you should write it directly as this. If the word cos doesn't come up, you should write it in this form. Either way, you should get your 5.1 centimeters. In this case, let's look at them. This is the side, start with the angle. This side is directly in front of the angle, so we know that this side is the opposite. We also know that this side is the hypotenuse. It is the longest one, and it is the one in front of the right angle. Now, which ratio, which of the three uses opposite and hypotenuse? It is sine. So we're going to say the sine of the angle is 48 degrees, is equal to the opposite side, which is x divided by the hypotenuse, which is 15.2. Similar situation here, do a cross multiplication. So we have 15.2 multiplied by sine 48, and that should give us x. Type that into your calculator. 15.2 times the sine of 48, and that should give you 11.3 centimeters, 11.3 meters. In this triangle here, we have a 45-degree angle here. So we know for sure that this side right across from the angle is the opposite side. This side over here is the hypotenuse. There's nothing on it. And we have this one, which is the adjacent side. Again, we say which ratio, which of the three uses the ones that we have. We have opposite and adjacent, and it is the tangent ratio that uses opposite and adjacent. So we go ahead and we write it down. The tangent of the angle is 45 degrees, is equal to the opposite side, which is 20, divided by the adjacent side, which is x. Do a tiny bit of cross multiplication here. You get x times the tangent of 45 is equal to 20. If you remembered from the lesson before, the tangent of 45 is 1, but I'm going to skip that step for now and just write x is equal to 20 divided by the tangent of 45. If you remember the tangent of 45, of course you can just write it, that this is equal to 20 over 1. If not, put it in your calculator and get your answer. So the adjacent side would be 20 meters. Also remember that in this case, because this is a 45-degree angle, this angle naturally here is going to be 45 because they would be equal, which means that this triangle is going to be isosceles. So if this is 20, then that is going to be 20. Lots of options here in working out the length of x, but I wanted to do it using the trig ratio. So this is how we use trigonometrical ratios to find the length of a side. Now let's use the trigonometrical ratios to find the size of an angle. Now, you need two sides to work with a ratio. In this question, we have the angle theta, and we want to identify the sides. So go across here. This is the opposite. It's right across from the angle. And this one is the hypotenuse. Let me write it down. Sine of angle is opposite over hypotenuse. Cosine of angle is adjacent over hypotenuse. And tangent of angle is opposite over adjacent. All right. So we have those three. 1, 2, 3. 3 ratios. So which ratio has opposite and hypotenuse? That is sine. So we say the sine of the angle is theta, is equal to 8 divided by 10. Now what we want to find is the angle itself. So we have to use the inverse function sine inverse to find the angle. So we're going to say that the angle now is equal to the sine inverse of 8 over 10. And you type that into your calculator using your shift sign or your second function sign. So we'd say the angle here is equal to the sine inverse of 8 over 10, which gives us 53.1 degrees. In this question, this is our angle, so we know that this side is right across from it. So this is our opposite. This side over here is our hypotenuse, but there's nothing on it. We're not using it. We're not asked to find it. And this side, therefore, is our adjacent. And which ratio has opposite and adjacent? This tangent. So we say the tangent of our angle is equal to the opposite side, that's 6 divided by 2. And so because we want to find our angle, we will say the angle is equal to the tan inverse, because we use the inverse function to calculate the angle, of 3. And the tan inverse of 3, remember to use the second function tan or the shift tan, and of 3 gives us 71.6 degrees. Now remember, if your calculator does not, if when you press the button for tangent and you don't see the letters TAN come up on your screen, then to enter this in your calculator, you would actually write the number 3 second function or shift tangent and equal. So pressing the button is in that order. If your calculator is like that, will give you the same result as it is here, without if you didn't have the calculator that allows you to write it directly. In this question here, we want to look at this side again. So we go across. We know that this is our opposite side, but there's nothing on it. But we have the adjacent side and we have the hypotenuse. And again, we want to ask the question, which ratio uses the adjacent side and the hypotenuse? Adjacent and hypotenuse is cos. So we'd say the cos of the angle, and the angle is theta, is equal to the adjacent side, that's 5/20. And so to find our angle, we're going to use the inverse one. So theta is going to be equal to the cos inverse of 5/20. And punching that in your calculator using second function cos or shift cos, we get the cos inverse of 5/20 is equal to 75.5 degrees. It's important that you learn how to use your calculator to find angles, as well as to use your calculator with your trig ratios to find lengths of sides. These questions are pretty straightforward, and students generally don't have any problems with these, apart from where they might mix up the sides and choose the wrong ratio. Let's continue here to talk about something else. Angles of elevation and depression is just a simple way in which we can apply the ideas of using trigonometric ratios to solve real-world situations. Imagine that you're standing on top of a building. Well, any person, once you're looking, will you understand and know that you cannot see around a corner generally with your naked eye? If you want to do that, you have to use an instrument. So we see in straight lines, and the line that you see in is called a normal. That's your straight line. Now, if something is above you, you would have to adjust your vision or adjust your head to look upward. And in doing that, an angle is created between the normal line of sight and the new line that you elevated to. And that angle is called an angle of elevation because you are elevating your eyes, so to speak, or your head, looking upward. And if you were to look downward at something from the normal, then that angle that is formed here is called an angle of depression. So this bird sitting in the tree, looking down at the dog, this here is our angle of depression because the bird is looking down. This is a normal line of sight for the bird. But looking down on the dog, this angle becomes the angle of depression. This dog on this level, however, looking up, this is his normal line of sight, and looking up, this angle is the angle of elevation for the dog, looking up at the bird. If you notice here, we have something that we call in math a Z angle, or what we call alternate angles. And alternate angles are equal to each other. So whatever size that is, this angle is the same size. So if that angle is A degrees, then this angle is also A degrees. They share the same size. How can we use this? Let's say we have a question here. There are two buildings. The buildings are 45 meters apart, and there are two windows. The first window is some distance up. Let's call that the height. And this is the angle of depression from the first building downward to the first window on that building down to the second window. So how far below the first window is the second window? And we are to give our answers correct to two significant figures. Let's concentrate on finding what it is first, then we can worry about the significant figures. So here we have a right angle triangle. And if we remember from here, then the angle of depression is equal to the angle of elevation. So we can safely put the 17.6 degree here and use it in this triangle. So what we want to do is to find the height here. We have this side, which is the opposite side. It's right across from the angle. And the other side here is the adjacent side. And writing our thing again, sine of angle is opposite over hypotenuse, cosine of angle is adjacent over hypotenuse, and tangent of angle is opposite over adjacent. It always helps to write it down so that you can use it. So we realize we're using opposite and adjacent, which means that we're going to be using the tangent ratio for this one. So we say the tangent of the angle is 17.6, is going to be equal to the opposite side, which is h divided by 45. Doing a little bit of math, cross multiplication here, we have that 45 times the tangent of 17.6 would be equal to the height, which is what we want to find. So if you remember, if your calculator, when you press the word tangent, gives you the word tan, then you would write this expression directly as you have it. If not, then you have to write it a different way. So 45 multiplied by the tangent of 17.6 should give you 14.3 meters. So the value of h here is 14.3 meters. If your calculator didn't get the word tan when you press it, then you have to write it a slightly different way. You'd have to write something like 45 times 17.6 tangent equal, and that should give you your answer. Or to put it another way, 17.6 tangent times 45 equal. Either way, you would get the same answer as if you wrote it indirectly on a calculator that allowed you to write it indirectly. Saying that again to say that you must know your calculator and know how to write different expressions on it to get the answer that you want. Here's another one. A man at the top of a lighthouse, so the man would be here. We are ignoring the height of the man in this question. A man at the top of a lighthouse sights a boat. There's a boat at an angle of depression of 25 degrees, and the boat is at a distance of 52 meters from the man. How far is the boat from the foot of the lighthouse? So imagine that this distance is measured in the air, because this is the boat, which means that this is water, and this here is the lighthouse. So we want to find this distance. And before that, we did not answer this question correct to two significant figures, so let's go back and do it. So the two significant figures, since it's saying our height is 14.3, then two significant figures here would just be 14 meters. All right, now that we fixed that, let's continue back with this. And that is actually important. When a question asks you to do something to a particular degree, then you need to answer it as is. All right, so here we want to find this distance, the distance from the boat from the foot of the lighthouse. All right, because we have this 25 degree here, this angle of depression is the same as the angle of elevation here, so we can put our 25 in the triangle and use it here. This side would be our opposite. We are not using it, nothing on it. We have something here. This side is our adjacent, and this side is our hypotenuse. Writing it down again, sine is opposite hypotenuse, cosine adjacent hypotenuse, and tangent opposite adjacent. Now, which of the ratios has adjacent side and hypotenuse? It is this one. So we use the cosine ratio here. So we say the cosine of the angle is 25, is equal to the adjacent side. We're going to just call that distance d for now, divide by 52. Here we cross multiply them. 52 times the cosine of 25, and that should give us d. So 52 times the cosine of 25 gives us 47.1. And our question says give your answer correct to the nearest meter, which means that our answer is just 47 meters. Let's look at another question that's a little more complicated. Like I said, questions like these, normally students don't have a problem seeing them because it's a simple diagram. But sometimes CXC does not give you a simple diagram. Sometimes they give you something that you have to look on it and decipher. And first up, let us look at this diagram before we even start answering the question. Let's look at it for what it is. The diagram shown is a rectangle, which means that this side is equal to this side, and this side is equal to that side. The point D is on HG, so D is on HG, so that DG is 12, and ED is also 12, which means that this side is 12. So let's fill in that. You can see the marks on that. That tells that this is equal to this. And we're asked to do a number of things. This angle is 43. We're asked to find the length of GF. Now GF is this side. And looking at it, this is our angle, which means that GF is the opposite. And we have the adjacent side. Nothing on the hypotenuse. We're not interested in it because the question is not asking about it. It's asking about GF, and we're given DG, which is adjacent. So to answer part A, we have to use the tan ratio. And tan, let's write it again. Sine, opposite hypotenuse, cosine, adjacent hypotenuse, tangent, opposite adjacent. The tan ratio says the tangent of the angle is 43, is equal to the opposite side, which is FG, over 12. Cross multiplying that, we get 12 times the tangent of 43, which gives us FG. There are no restrictions on how to write this. Well, it says here to write it into one decimal place. So we type it in 12 times the tangent of 43, and that gives us 11.2 centimeters, observing our one decimal place. Once we have that, it says now find the length of HD. HD is this side. So how can we find the length of HD? Well, we just found this side, FG. And since it's a rectangle, opposite sides are equal, which means that this side is 11.2, which also means that this side is 11.2. So we can use the Pythagoras' theorem to find HD. And Pythagoras' theorem really says that in a right angle triangle, if you, the length of the two shorter sides, the sides that make the L, if you take those two sides, square them and add them, it will be equal to the square of the longer side, which is the hypotenuse. So we can write here in part B, HD square, that's this side, plus 11.2 square should give us 12 square, which means HD square is equal to 12 square minus 11.2 square. So you can punch that in your calculator. 12 square minus 11.2 square. And that should give you 12 square, which is 144 minus 11.2 square. Just punching that in. 125.44. And you do that subtraction. If you want to take the long root out, 144 minus 125.44, you would get 18.56. And now we need to find the square root. So the square root of 18.56 would give us 4.3. So the length of HD here is 4.3 centimeters, correct to one decimal place. That is part B. And we still have another side part to find. We want to find the size of angle HDE. HDE is this angle. If we should separate that triangle here, then you would see that we have a lot of options to find HDE. HDE is here, HDE. And we have this to be 12, we have this to be 11.2, and we have this to be 4.3. So we have lots of options. We have the three sides, so we could pretty much use any ratio to find it. So we can just say, using this one, the sine of the angle HDE is equal to the opposite side using sine 11.2 over 12, which means that HDE is equal to the sine inverse of 11.2 over 12. And once we put that in our calculator, second function sine of 11.2 divided by 12, we should get, for our answer, 68.96 degrees, but it wants it to one decimal place, 68.96. But this actually turns out to be, when you round it off, it turns out to be 69 degrees. So that's how you'd actually tackle this kind of question. Part A, B, C. All right, let's look at another one. This is our final one. The idea is that you know, in order to become efficient and skilled at using the trigonometrical ratios, you just have to practice a lot of questions using them. And in order to remember what the ratios are, you keep writing it down every time you want to use it. So let's write it down again. Sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. All right, in this question, we are told that the diagram, not drawn to scale, that's important, shows ABC and PCD are two triangles. And angle ABC is 40, here we are. And AB is 10. AB is 10, so this side is 10 centimeters. And PD is 8, so PD is 8 centimeters. Here's PD. And BD, the entire length of here, is 15 centimeters. So we're asked to find the length of BC in centimeters. What is the length of BC? BC is the adjacent side of this triangle. Now let's separate that triangle there. So let's take it out and write it by itself. So we have that triangle, that side to be 10. We have this angle to be 40. This is B, this is C, this is A, and sometimes this is a very good strategy when you're looking at a diagram that can be complicated. Just split it up into smaller diagrams so that it will not give you any headache. So we have this side is 10. We want to find BC, that's this side. Using our idea here, we know that this side is adjacent because this is the opposite and we're not using it. And this one is named. It has 10, so, and it's a hypotenuse, so we definitely know we're using cosine. So the cosine of the angle 40 is equal to the adjacent side, which is BC over 10. And we do that cross multiplication here, so we have 10 times the cosine of 40 gives us BC. Punch that in a calculator. 10 times the cosine of 40 gives us 7.66. Rounding it off, it gives us 7.7 centimeters. So that is the length of BC. All right. Having that, we need to find the size of angle PDC. So PDC is in this triangle over here. So let's separate that triangle. What we know is that this side, PD, let's write that a little better, PD and C, we know that this is 8. We need the length of this side. We don't know it yet, but we knew that the entire length was 15. The entire length BD was 15. And we just calculated BC, and BC is 7.7. So this section has to be the difference between 15 minus 7.7. And 15 minus 7.7 is 7.3. So we know that this side here is going to be 7.3. Having gotten that answer, we want the angle PDC. PDC is here. This angle is PDC. So this side is adjacent. This side is hypotenuse. So we use cosine again. So we say the cosine of PDC is equal to adjacent 7.3 over 8, which tells us that PDC is equal to the cos inverse of 7.3 over 8. Just going to erase this. Divided by 8. And punching this in our calculator, we have that PDC equal to the cos inverse of 7.3 over 8. That we go second function cos 7.3 divided by 8, and you get 24.1 degrees. So it's important that you know how to use your calculator. Whatever scientific calculator you have, it can be effective enough to handle your CXC exam. You just need to know how to use it. So what I notice with a lot of students is that they buy a brand new calculator, they get a manual with it, and the first thing they do is throw away the manual and start using it. If you're an expert at the calculator already, that's fine. If you're just starting to use it, then I suggest that you look into the manual to see how you should write specific things. And usually that manual gives you examples of how to write them out to get the correct answers on your screen. So know your calculator and practice a lot of these questions so that you can master them, because sometimes when CXC gives these diagrams, they can be tricky. One strategy is to break the diagrams into parts like I did here and take them apart and see how they fit together again. And generally, just practice a lot to make sure that you develop your competence with them. Thank you for watching.